Okay guys, as I promised you, I'm gonna give you a hand with the exercise number 25. So listen up. Part A, it says how high a hill can a car goes up, engine disengaged, if work done by friction is negligible and its initial speed is 110 kilometers per hour. The first thing we have to do is transform that speed into meters per second. So let's do it. 110 kilometers per hour must be multiplied by two fractions. And in the first fraction we're going to place the kilometer in the denominator and the meters in the numerator. And remember that 1 kilometer is made by 1000 meters. And we must place the hour in the numerator and the seconds in the denominator. And remember that 1 hour is made by 3600 seconds. When we multiply and divide, we will get 30.56 meters per second, because we cancelled the kilometers and the hours. Okay. In this exercise, we have to use the equation for conservative systems, since there is no friction. Moreover, since the engine is disengaged, the car won't speed up, so it will climb with its initial speed until gravity makes it stop. So we have an initial situation and a final situation where the car has achieved the maximum height. So remember that I told you that we have to use the formula for conservative systems. That means the initial potential energy plus initial kinetic energy equals to the final potential energy plus the final kinetic energy. Now, the formula potential energy, it is the mass times the gravity times the initial height plus the formula kinetic energy is the half of the mass times the initial velocity squared equals to, and once again the formula potential energy, it is the mass times the gravity times the final height plus, and the formula the kinetic energy, the half of the mass times the final velocity squared. Okay, let's analyze the first term. Mass times gravity times the initial height. The initial height is 0 meters. So, the first term disappears, since the initial height is 0 meters. Well, okay, we will keep the second term, the half of the mass times the initial velocity squared. And why do we keep it? Because the mass is we actually don't know it, but that doesn't matter. The mass is not 0, it's a car, and the initial velocity is 30.56 meters per second. The final height, we still don't know it. Actually, that's the unknown. And let's analyze the fourth term. The final velocity, it will be 0, because gravity made the car stop at the highest point it could reach. So the fourth term disappears. So we will keep just these two terms, the half of the mass times the initial velocity squared, and the mass times the gravity times the final height. And we can cancel the two masses because they appear at both sides of the equation. So it will remain the half of the initial velocity squared equals to the gravity times the final height. Remember that our unknown is the final height, so we must send that gravity from multiplying to divide to the other side of the equation. So we will have the half of the initial velocity squared divided by gravity equals to the final height. We have the initial velocity and of course we have the gravity. So let's replace all of that. That will be a half of 30.56 meters per second squared, and all of that divided by 9.8 meters per squared second. That's the value of the final height. You do those calculations and then you will find the final height. Good luck!